Mayr, who I think many of you will know from his book on the type of origins of feedback control. Otto, would you like to tell us something about your education, about particularly your undergraduate education?
Yes. I was educated in Germany, worked in Germany, and so went to German schools. And undergraduate, to the high school in Germany, high school before I went to high school in a small town, middle of a small town, and the school also was a school which I had very little respect. It called itself gymnasium. Gymnasium in German means classical for new languages, foreign languages. But we did it quite a bit. And otherwise, a lot of English and a good bit of French, but not enough. In most cases, they could. And so this was a school I didn't like much, but in the end, I made it precisely because everybody who graduated from it, they hadn't learned much. But a lot of successful people. For example, at the Technical University of Munich, when I was in Munich, my immediate and two almost classmates of mine as professors. So that's the thing. And then I went to the Technische Hochschule Munich, which is the Technical University of Munich, and of course it's a Technical University. And I did mechanical engineering there. High school, I graduated in 1951, which meant I was born in 1930, and I was really awfully old to graduate, and the last 2 years, that's what I wanted to. And so in Munich, I was from 51 to 55. I graduated at the end of 55, and so that was that. And then so they want to get more education.
Well, could you, when you did your mechanical engineering course, can you remember whether you did any control as part of that?
I certainly can remember that. I did not. This was, control in Germany. To say it was backward would be probably unfair, but in the course of the 50s, sort of concurrently with what I'm right now, but during the 50s, I think the control theory and practice, as was practiced in America, I think became acceptable. And I think what they had done in Germany was they had approached it quite differently. And I think they called it a different language. And so whatever was offered at Munich at the time was, of course, that other language. It was very mathematical. And I think they did it virtually without using the concept of feedback. There was a word that we could talk about, but something like this maybe later, that was equivalent of feedback, but I don't think it played a role in the German as it did in the Anglo-Saxon approach. And I didn't know anybody who went there who was considered esoteric and difficult, and I never was particularly famous in mathematics, and I did not seek out subjects that were mathematical. It was sufficiently challenging getting past the mathematics and the normal mechanical engineering that I encountered. So no, I didn't.
So when did you first encounter feedback as an idea?
Well, okay, it's in my little talk. It's a distinct moment. I came to America in 1956, and I have to mention the occasion. I have an uncle who's a very famous biologist, and he's my godfather too. So my father was the eldest and he was the second. And so I had always been corresponding with him. Well before there was an understanding you come to America as soon as you get out of the school. And indeed, the way you graduated in Munich, here you graduate with gowns and hats and speeches and celebration. there you do all your courses, pass the exams, or go somewhere, they don't care. And then you finish the thesis, the diploma. And so I did this diploma when I was not about to take it seriously. So I climbed mountains as long as I could that summer. And when the weather got bad, I went home to a little provincial town in Westphalia and sat down and wrote this thesis. And so between really in the last few weeks before Christmas and even over Christmas, and then between Christmas and New Year's, I stuck this thing in the Mayr and sent it to the legislature in Munich and told me this. And after a few days, I called and asked, "Is this okay?" And he said, "Fine." And so then I went on this team early in January, and my father had worked in St. Louis out where I could work my way over. It was called a freight application from Otto. And so I got into this thing, and then I arrived in arrived in Norfolk, and late for the train. And then I took the Greyhound bus into Cambridge, and I had my uncles, and then I was sort of sucked into the life of Cambridge on Harvard School, something that was very good. And then I got into MIT and sort of joined this thing. And there I heard this word, even on the radio, in conversation, this word feedback. I had no idea what this is. But it's a simple word, and it didn't catch enough immediate attention for me to immediately ask, what is it? But when this word came up and again, I asked Marco, what is this feedback? And then he gave me the long explanation, which must have been more or less what he retained from reading Norbert Wiener. And after trying to follow him, I said, "You mean like a steam engine company?" "Yes." "Well, then I know what feedback was, So that was in 56. And before that, you can say I was totally innocent.
Did you, you said you heard the word on the radio, and did you notice any books about it at the time, any popular
articles? If anything, it was Norbert. Now I couldn't tell you. I mean, when I heard the name Norbert, I couldn't possibly say probably more than maybe. Probably my uncle said, "Well, you have to read Norbert Wiener." And sooner or later I did that. And I don't know how you all deal with Norbert Wiener. I mean, we're talking about the cybernetics book, There was also a popular set. There were two cybernetics books, if I remember. One was more academic, another was more popular. But they all start off pretty friendly, and so you read as far as you can, and there comes the moment when we talk, But for me, that was not. You can gather it from looking at what I published. I sort of had warm feelings for Norbert Wiener, even if I, followed him only up to a point. And so I read quite a bit. He wrote fiction, and so I read all that. And I liked it, Okay.
I'm trying to remember. Was he still alive?
Oh, he was.
Yes.
Sure.
Did you ever meet him?
No. My uncle said he was the worst of all, and everybody avoided him because my uncle said he had a way of getting in conversation closer and closer to you, and then you would get a button on your jacket and start turning this button until it came off. So at the Harvard Faculty Club, they dreaded getting involved with him. This is the gossip that goes on between professors, especially MIT versus Harvard professors.
Can you remember anything of the courses you took at Harvard, at MIT?
My engineering career was deeply misguided, and I couldn't carry on with that. But I've already sort of laid it out. The reason was my father was an engineer. I came in, the formative years for me were, I imagine, sort of adolescence. It's especially in Germany, if you were a good kid, you know what you're going to be. You know, it's not to say, I'm not going to ask you what you're going to be, what you're going to study. If you wanted to be respected, you know what it was. And to say, no, I don't know, that was the mark of a jerk, you know, the mark who didn't know what it was doing. And so I relatively early, meaning as soon after work, I decided I would be an engineer. My father was an engineer, and not a particularly good one, because he probably wasn't even less gifted for it than I was mediocre. I mean, I was perfectly okay for sort of mediocre aspirations, you know, but to come to the top, no way. I mean, I might have made a decent salesman somewhere, but as an engineer, I thought I had dreamed of being a designer. You know, being drawing about designing creative things, you know. But anyway, so my engineering career started out entirely on the wrong foot. So my father gave me all kinds of advice into having these factories, and he was chief engineering on Coleman. And he got into this job only at the beginning of the war. Before he had worked for Krupp in Essen, in what do they call it? The railroad, but not motors, but railroad carriages and the woodbed stuff, switches, turntables, and stuff like that. And so he was something like a chief engineer. He was the head of the design office, in fact, and also then he got into production. But when the war started tightening up, he thought Essen is not the place we want to live now, you know. And so he got hold of this job at the periphery of the war. It's Coleman, and he thought it's got to be a safer place than Essen. So we moved to this terrible place, okay? And in fact, my parents had built a fairly nice house south of Essen, basically in a yuppie neighborhood of the 30s, you know. And that house came through the war absolutely unscathed, where at least in this Dutton place where we lived, we got a modest amount of bombing. It wasn't bad, but at least gave us a taste. But even this opportunism that my father didn't pay off, you know. Anyway, so he was on this Coleman. And on this Coleman, he was in charge of the power plant, among other things. This power plant sort of blossomed forth into, let's say, power plant that even fed into the general utility net. So my father thought the ideal life of an engineer is to be the head of a power plant, you know? And so he thought there is nothing better than to be in charge of the power plant. Well, and so what was I to say to this? You know, I swallowed stuff like that, you know? And so in Munich, I did like turbines. And I liked the thermodynamics, you know, these cycles, you know, these circular processes, these thermodynamic processes. This I thought was smart, you know, and I loved turbines simply for their good. And so I went into this power plant option, and let's say power engineering, something like that. And that was all right. And okay, so your question was, what did I do at MIT? Well, what else could I do except fall back into that? And so they put me into the heat power lab, and in addition, I came at MIT. I arrived for the spring term, and I arrived about 3 weeks late. And I had not the slightest idea how the American academic life works. In German, academic life worked then, and to some extent, I imagine even now, the courses, things you don't really you register in a sort of very general, nominal way. Nobody checks whether you ever come to any class. You just amble in there if you feel like it. If you don't, you just don't go there. And you're not going to be tested. The exams come at another time, later, and are relatively independent of on what happened in these lecture courses. And so you can take a sit in there and see what's happening, and if you find the system not to your taste, you just stop on. And so I didn't get at the beginning of the term, I don't know. And then I got 3 weeks back. So I didn't understand what went on. So they asked me what you want to take. And I thought, well, I probably should sort of take it easy. Should take some of the courses to get to learn the lingo and get kind of put my feet on the course. So I took a couple of undergraduate courses. One on gas turbines and one on differential equations. And then I got through those, and then these were undergraduate courses. And so they were graded on the different curves in graduate courses. So there, the average grade was a C, whereas for graduate courses, the average grade is a B. So I got C's. And that didn't do me any good, And I didn't realize, I thought, so I'm just moving, why should I? What do you expect of me? And coming here late, I have to catch up on these courses. And of course, you're in the shark's form, because these are the brightest undergraduates in the country, with whom I can compete, and so on. So that was my beginning at MIT. So after a semester of that, I had to ask what was going on. So of course I was taking good undergraduate courses. And then I took a course on something more or less to the effect of design. That was an IEEE course. And then I took fluid dynamics. That was a standard.
So it was a standard, very standard engineering.
Sure, yes.
And when did you, as an engineer, really begin to come across control?
Okay, I'll tell you. But before, I want to add one more item. So I don't know why, but I had some sort of a mentor who was a young assistant professor, and this IEEE project that I was on was also his dissertation, heat transfer, boiler heat transfer. And him I asked at some time, what about control engineering? And he said, that's a subject for stupid people. All they do is differential equations. It's boring, it's straightforward, and I don't respect it. Okay? So, interesting contrast to what I heard about it in Munich. Well, you see, by that time I was sort of hard pressed. I think in a better world, even then, I might have been in the mood to try that out, just to see what it was, But by that time, my grades, my average was bad, and I was really trying to think it made it. So I wasn't experimenting anymore. Okay, now when did I? I guess tenacity is one of my virtues, including the failings of that virtue, And so, after I recognized that this heat power plant nonsense was really, first of all, it wasn't much fun, and after a while I recognized that was quite wrong in several other ways, but I still pursued it. I did it at MIT. I got this little job in Iowa, working for a consulting engineer, building power plants on the that was cool. And then I went back to Germany. And for some reason, I didn't want to work in Germany, and I couldn't see why that was. But partly because my father dominated the scene. He told me where to go and with whom to talk and what not to do, whom not to talk, and all these people that he talked to made me wonderful offers, And so that was something it basically made me blind when I made my hair stand. So I went to Switzerland, where nobody knew, and worked for a celebrated traditional mechanical engineering firm called Switzerland in Winterthur. And there I got a job. I got basically the job that they give to young engineers out of the technical universities. And so, first of all, this was a very traditional firm, and it virtually doesn't exist anymore. They were so traditional they basically eliminated themselves from the field. But so they put everybody into the design office, big drafting board and a white lab coat on, and that's what you did for a year, whether you liked it or not. And so I did that. Because after all, I always wanted it, and that was a stupid move. And smart friends of mine in New York, they can ask me why I did that. I somehow wanted to do this. All right. No, wait. What was the question? How did I rise up? Okay, fine. So after this design office stuff was just too stupid, so I asked them, please let me do something else. So I said, okay, project office. That meant they get incomes. They have the sales force around the world, and all these salesmen run around and try to get somebody to show interest. And so soon as somebody shows interest, of course, they have to somehow sketch out this little boiler and put a price tag on it. That's what we did. And so I was in there. And, well, of course, so I was there for 2 years. And as this went on, I realized that the life cycle, the life cycle begins with this offer that's made in this project office. And then, of course, let's say 1 out of 50 becomes an order. So then this order gets concluded, and then after many months this thing gets produced. I mean, first of all, it means only that in the pipes, in the workshop, in the literature. And then this all gets shipped down to South America, some other place, and then all leisure it gets put together. And probably it is after the first project was designed, or maybe later, this thing is fired up. And that turns out this idiotic. How many life cycles do I see in my life? It's like, this is too slow, And so I mean, the Sulzer company had driven me crazy already by its traditional ways of carrying on, So, and besides, in Switzerland, especially then, a German was a foreign worker, simply, And I could understand that, but still, I was the victim in this case, and I didn't see what I needed to do, And my wife wasn't married there, and so she said, let's go back to America. Let's do it. So now I wasn't going to, so I wanted to start that move. And in both senses, I always liked gadgets that move, and the boiler, nothing moved, except maybe water in the pipes, but you don't see it. Maybe the needle goes like this, But that I thought isn't enough fun. And besides, if this happens every 8 or 10 years once, that's too slow. And so by that time, I had really worked out that control engineering would be a very good way of doing it. But still, so then I had written a few letters, got no answer from literature, got no answers. So we went to where she came from New York. And so there we lived with the gun, with the pencil. And I knocked at some doors. This was the end of 59. Knocked at doors in Buffalo. And basically I looked at two kinds of things. I looked at turbo machinery, and then at instruments control. And so I can't remember. I knocked at 3 or 4 doors in Buffalo, and then I thought, just to drive down the road. But I also, I did have a fairly attractive offer from GE in Schenectady, in the turbines, And then in Rochester, I didn't really know much about tailors, and so I had a sort of a list, a little on the old envelope, I had some names in Rochester, so I drove down there. We had come with a little VW, which we had put on the steamer and on the Mauritania, and put it on in Cherbourg, took it off in New York, drove up to Buffalo, and this was Beetle. So with this Beetle, I drove to Rochester, and basically knocked on the doors on my list, and the tailors, don't know, they drove up to the plant, and at the front door I went in and said, I'm looking for job boards, And they said, okay, why don't you take a seat? And of course I said, and after a while, somebody came down and said, are you looking for job boards? And asked me questions. And I said, and then that's it. I'm offering it in the application engineering, they call it. All right. And money was a little less than GE, but not idiotically less. So I drove to Buffalo, and then we just considered the situation with relatives over drinks. His uncle said, money talks, which meant going to. Did I say Schenectady? In Massachusetts. Oh, no, it's not Schenectady. So then, I thought this control was not enough, and I like the idea of smoking. And so that's what.
So when you joined Taylor Instruments, you say you joined as an application engineer.
Yes.
What sort of jobs did you have? And did you was it simply using the controllers? Were you put through any training courses to learn that?
Yeah, they did that too. And I came into the application engineering department. The application engineering department changed names after a while and then called itself systems engineering without any change in what they did, but it sounded much better. And so then in it was a group, everything included, of between 15 and 20 engineers. And so it was a place where everybody knew everybody. They were low-key and friendly and very informed. And I was put with another guy who was younger than I, and I was sort of doing the role of his helper in the beginning, and he was in charge of the transcode line. Does that mean anything?
Yes, the transcode.
Okay, the transcode line was a plug-in system, so on the face on the control panel was about this big, and it was a long thing sticking into the back of it. It was pneumatic. It was a line of controllers, but you could plug it together with all kinds of things, recorders and the various, converters. I mean, the things that receive measurements and convert them into that language, stuff like that. So we were in charge of that. And what we did is, the job had two levels. One was designing control systems. So the application engineering department worked extremely closely with the sales department. So again, they had a sales force swarming all over the country in various ways of structure. And so salesmen had inquiries, and then they relayed the inquiries in and said, make a proposal, which meant, of course, design a system. Design a system sounds bigger than it was. But it was process industry, chemical industry usually, and they wanted to control temperatures, pressures, flow rates, or even interesting mixes of several signals put together in some form of algebra to put together a complex measurement, or control, but nothing very complicated. And so then we were basically in this work, you could do this with a soft pencil without on paper, lay out the system and say what the controller was and what the responses were and what the transmitters you put in and what else, the valves, size the valves for the fluid, stuff like that. And we set that up. And so here the success rate was a lot better than in the case of Sulzer. So often this stuff was ordered, and then of course you would go out there to supervise the installation, and when they fired everything up, you'd be there and make adjustments. And you also would be called in for troubleshooting. And concerning the troubleshooting would, I mean, troubleshooting would happen in both places. First, it happens at your desk. You can get phone calls, and he describes what's ailing him, and you give him advice, and often you could tell on the phone exactly what he needed to do, and that was the end of it. If it wasn't, you could catch the plane, go out there, see what it was, and often you could fix it. And if you couldn't, you get back on the phone and talk to other people, including the design department. And if that didn't work, there was a research department.
So how in doing that, how much information did you get about the planet that you were going to have to control?
All you needed is all I can say. Well, the controller doesn't care how big the plant is, but the valves. It had to. The valves have to be sized exactly right, or you had nothing, And so that's the only thing that mattered. And so that was. So you needed to know if it involved temperature, you needed the temperature range and then select the proper thermometer. If it was flow rate, you had to pay attention to that. The orifices had to be sized
and what mechanism, what did you use in terms of seeking to tune controllers? Was that the plant engineer's job, or did you?
No, basically often you could tell from the nature of the problem which responses it needed. There are certain processes where you perfectly well. You didn't need the derivative or the integral response. And some you had them all three, but you could turn one or the other of the responses to zero. So it was as good as non-existent. And so basically you had some kind of tactics, let's call it, for firing it up before you did anything. You put them on safe settings and then turn them up. You had the nice controller that would draw responses for you and things, and so you did it. So, it was a matter of 15 minutes. Depending, some processes are extremely slow. Then, you give it a step response, and it may take an hour before it shows anything. So then you have to be patient. But most of them, you get the response very quickly, and then you get the nice damping curve. And if the curve looks nice, what do you want? So basically, that's how it was done.
Were Ziegler and Nichols still there?
Yes. Yes.
Did you meet either of them?
Yes, I met. Somewhere, if I had dug, I could have shown you a picture with me and Ziegler in it. And that was, but Ziegler was a salesman, and I don't know why, but he was a salesman in New York, and he would turn up once in a while, and he would be greeted with a certain amount of boisterousness, and of course he was, let's say, an elderly aristocrat, and I was a nobody, so it wasn't. I didn't expect him to pay attention to me, but this line that we had, the transcode, was basically their best line. So any case, I don't know why, but we were showing him something, and so here was this picture of me, and then the other guy sitting in front, and Ziegler looking over our shoulders. So, and you could say that's as far as the contact went. Nichols was head of research. Now, research means development, of course, but they call it research. And Nichols was charismatic. He impressed me enormously. He was basically a very good-looking man, but he was running too fat. He was quite fat, but he had somehow he made a big impression on me. And he was very sort of low-key and soft-spoken, didn't say much, and if he was presented with a problem, he wouldn't say much, so nodded his head, shrugged shoulders, but I didn't make any weighty pronouncements, but he was respected, clearly. And he made an impression on me by being fired over a weekend. There was some Monday when you were told he was fired last Friday, and he'd gone already, and went off to the West Coast. Why? I don't know. I was not connected well enough to be told why it was. I just simply don't know why it was fired. And my rhyme for it was, Taylor paid for it, and I could imagine it was simply the pay. But I don't know.
When you were there, you're saying you were working with the transcode line. Was there an electronic control being developed?
Yes. Not only developed, it was there. And if it wasn't called transcode, it was called something extremely similar, and it looked, it was stuck into the same box that the transcode line was stuck into. In many ways, it was analogous. It was similar in its general configuration. It was also built to be very compatible with the transcode, so at various interfaces you could go from one to the other, and from pneumatic to electronic and back.
And were you aware at all of any use of digital computers coming in for process control?
This electronic line, of course, was thoroughly analog and digital. The reason I hesitate is I could not say no. I was not aware. But this was awareness, let's say, a beginning of awareness at the lowest level. And I can offer two anecdotes. One is at anecdotes. I'm thinking of it. Was on your letterhead. Anyway, anecdotes is historians have begun anecdotes.
Anecdotes is not the plural of data.
The plural of anecdote is
not data.
The thought is a little complicated. In any case, the simpler of the two comes in a little later. I did tailors for roughly 3 years, 2 or 3 years, and then went to teach at RIT. And at RIT, after a while, not from the start, I had a boss, a dean, and he came fresh from a PhD at Carnegie Tech in computer engineering, or computer science. And so we knew nothing about computer science, and he was a great prophet of computer science, so he set us down to give us a little instruction in computer science. And basically what we did was a sort of elementary finger practice in binary calculations, and it was really limited, and even more elementary bits of programming. I didn't last very long, but this is what you learn when you went to your PhD in computer science at Carnegie Tech. That was, let's say, 1 year later. And at Taylor's, there was mumbling or talking about certain measurements being, translated into digital signals rather than analog signals. That is what I heard. So, and I might even have heard of converters that translated, first of all, this measurement for like temperature coming out in a digital signal, and this signal, a digital signal, getting translated to analog to enter these machines that we had. This way it was. That I can't remember any talk of digital control, but then I was hardly at the cutting edge of this kind of stuff.
Who was the dean who
His name was Kirkpatrick. And Kirk, I doubt that you heard of him. He was somebody who enjoyed being a dean, and he became. There's a funny school in Boston called the Babson Institute, and they trained. I hope I'm getting this name. Very well known. In fact, they had also made me an offer before I went to Taylor, and they trained industrial technicians. They didn't have a bachelor's program, only some kind of a 2-year technician's program. And he ended up being the president. So he made that kind of a career. So I'm sure he never touched digital anything.
Can you remember when you first had any formal instruction in control theory?
Yes, well, and this is a very conditional yes. The reason I'm stuck. Now, how do I tell the story? Now, let me start at the beginning, at the Taylors. You asked me, what did they do to break in their new companies, And I told you the more important half of the story. How they basically threw into the cold water, except the water wasn't all that cold. But besides, they had a running course. They always ran courses in teaching people. Well, you could call it introduction into application engineering, the Taylor way, but that was mostly designed for the sales force. And this was, I don't know whether it was 2 weeks or 2 months, I can't say honestly. This was conducted across town, Rochester, where the research department lived in a little campus there and so on. And so I was put into this for a few weeks. And so I did that. And there, they threw quite a bit at you. And these salesmen were not expected to understand all of it. And now I didn't have a particularly successful career behind engineering so far. So I was motivated that I was going to be good at this, So I really made an effort, and I did well in this. And I even then, I had never up to that point understood what these responses meant. I didn't even know what feedback was exactly. I certainly didn't know what proportional meant in integral and derivative, Okay, and so this was already explained quite nicely in these courses by the better people from the application engineering department. And so I got to get to know these guys that way first, and so on. And then, as soon as, and this continued seamlessly when I was over there full-time doing working in the office. And so then, for the question, if I asked more questions about the theory, they told you what books to use, and also their tricks, There was something, the name ZOS, does that mean anything?
Yes.
He had, and don't ask me his first name, he had some kind of a graphic frequency response. He had some kind of a frequency response technique for figuring out controller settings, something. And then you heard there was Ziegler-Nickel settings. I don't even remember what it was. So, but I heard all about these things there. And they must have been textbooks where you could look up things. And in the end, I felt fairly competent with these things. But I took a course at the University of Rochester. And there was somebody whose name was Jerry Cohen. Does that mean, and I think Jerry must have meant Gerald.
Yes.
And he was, and I think I also took an electronics course from him. And I think control, automatic control course. And Jerry Cohen was not an organized person. So this course was not anything that was very easy to understand. Because he sort of, it would have been maybe more enjoyable for a person that was more self-confident in the business than I was. But nevertheless, you asked me in the letter what the textbook was, and I can tell you. But it was not the textbook that was overly helpful, really, but on the other hand, there were plenty of textbooks around, and others were understandable. And in the end, I got so that I was very confident in this. Well, there was an elementary theory which was sort of had reached a new level of maturity. They're using these Laplace operators, sometimes people talked about East Side operators, but it was sort of translating all that calculus into a level down into ordinary arithmetic, and it was very easy for setting up linear differential equations. I mean, as long as it was linear, it was wonderfully limited, this stuff. And we also built analog setups. We simply took a transcode controller, and you could make an analog with a computer, pneumatic, of course, and make pneumatic analogs out of this. Anyway, that's all I can think of. Otherwise, the University of Rochester didn't offer much in control. And Jerry Cohen was not charismatic enough that I went through the same, and so then ended up, and also the University of Rochester. I'm wasting time telling irrelevancies, but they had went through something that was rather common in America those days, early 60s. They went through a complete transformation where the principle was throw out all the old deadwood guys and get in all these sharks from MIT, And so these poor old professors who hadn't done anything in 25 or 30 years, they were taught, they were basically making my life unbearable, so they would retire, or simply. So then, in one case, there was one guy who had always taught thermodynamics, and they stuck him with teaching a course in tensor calculus. That's what he had to do. And he, with a smile, did. I took that course and he did that calculus. And I learned a lot in this tensor calculus course, And these whippersnappers from MIT, they were just as big shambles as some of the old guys, and it was chaos, And so basically, what was going on in the Europe was on a high level completely useless.
I wonder if I could perhaps take us on to how you came to write the book on the origins of feedback control.
Well, it has to do with that I systematically checked off on some kind of a checklist all the things that you can do in engineering to see if I might like it. Because so far everything I didn't like. And also at MIT it was research, then at Zulsa it was design, now at this project business, and then the tailors. That was enjoyable, only it was innovative. It was not particularly challenging. Also led. And so then here was teaching, of course, this was really teaching at a low level, but I was not qualified to teach on a high level, so I was glad that they let me do this, and I did. I think it was a perfectly good success. But there I thought, how can I justify before my conscience to teach those poor guys this miserable profession, And so then I thought, I have to get out of this, And so I finally came upon the history of technology. And by good luck, I got this offer at the Deutsches Museum, which was simply a nicer offer than going to an American graduate graduate school to become a historian of technology. And so in American graduate school, they put you through rigorous training. And in Munich, they basically left me to myself, let me do what I want. After a while, I recognized I have to pick my own dissertation topic, so I thought I can do it. And so I picked the history of funeral, and so we did this dissertation that ended up in this little book that we all know. That's the story.
Yes. It just seems to me that here's you, an engineering background, and you choose as a dissertation topic to go into what to many of us would seem to be a very difficult area, which is going back over a very long period of time. How did you it seems very challenging.
Maybe like it getting stuff.
So, how did it seem challenging?
No, it seemed easy. To me, it seemed easy. But now you have to see. I mean, again, I had burned my bridges. After going in Rochester. I mean, I could have spent my life at RIT in Rochester. I would have sort of, plugged my way through a mediocre engineering teacher's career. And it would have been in an undemanding, uninspiring way, perfectly pleasant. And we had a lovely house in Rochester. We had a nicer house than we've ever had since. And so to go to Munich into this crazy adventure, we sold that house, put the furniture into storage, uprooted 3 little kids, went to Munich, for this. So I had burned my bridges. If this didn't work out, I could have jumped off the bridge, So it makes the metaphors nicer. Anyway, I knew this had to be a success. That much I knew. And then, but I also knew, first of all, I wanted to become a historian. I thought I had solid proof that I wasn't going to amount much in engineering. And so if I was going to amount to anything, here was my chance and my last chance, I thought. So on that level, I was extremely determined. And now, with the feedback, I could have picked some other subject, but I don't know why. Early on, I was obsessed with this subject. I thought, this is the hottest subject that this world contains, that anybody could discover. And I was really worried that somebody else might snap it away from me, And I mean, when you're doing this thing like that, you always exaggerate your own importance, So I thought, this subject, on the whole, it did not let me down. I think it's, this little book, and it's really a modest little, it's done wonders for me, And that is because it was such a good subject, But suppose I hadn't come up with that subject, I would come up with some other thing, and I'm sure I would have produced a decent dissertation on anything, within that system. But with this thing, like a sleepwalker, I thought, this is a marvelous subject, a deeply important subject. And so I simply did it. And I found that nobody particularly paid attention to it. It was on the Munich scene, it was not considered particularly important. It wasn't what they did, what other people did. And so they left me alone. And I didn't need anybody to tell me what to do. Clem was one of my sort of senior advisors, or thesis advisor, or whatever. He was wonderfully helpful in telling me what books to look in, or what sources to look in, to find where I might find something. Because if I came up with a list of the early examples of feedback control, it better be a reliable list. list. Because if somebody else went over it and found all kinds of stuff that wasn't in my list, I would have looked poor, And also I would have looked silly if I had identified stuff as feedback which other people came and said, and also it had to be reasonably exhaustive, and it had to be correct in my identification. So this I did basically. There's one anecdote if I can, burst the time frame with it. There was an old guy, but who had written a well-regarded theory textbook on control engineering in the German style, fairly mathematical, and from Megadeth was the name, but I'm sure you don't know the name, nor need you. And now he had worked for Siemens, was retired, and I had heard of him, and I heard that he was now doing the history of this, and he lived around Munich, or where did I go? I don't know. Anyways, I wrote a letter and said I'm doing this and that. And he said, okay, maybe we'll get in touch sometime. And so, I don't know why and how, but Siemens had an archive, a fairly big archive in Munich. And the head of this archive was often it was sort of used as a sinecure for elderly important scientists, even if they had nothing to do with what archives and archivists do. And so I have a hard time reconstructing the details. Also in this archive was a guy who was an authentic historian of technology, but he was an underling archivist under this other guy. And so I went to see my friend, this underling archivist, and then I somehow was introduced to the big shot head of this archive, and I told him in my innocence, I'm doing the history of feedback control. And he said, what do you mean you do the history of feedback control? We do the history of feedback control. And I said, well, I thought I do it too. He said, no, you don't. And if you know what's good for you, you stop that. And so I went home. Was this slightly wounded? but I sort of could count on my fingers that there wasn't much he could do to me, instead of this threat. On the contrary, I started systematically bad-mouthing him. This strange attitude, And then after a while, I met the old guy, so Megadeth, and we had a chat. Very cool, but courteous, and I was far ahead of him already. And he came up with a book much after mine, and it was not a clear-cut. It was not in a clear-cut way focused on feedback. There was feedback, and there was various sort of automata, program type of control. It was basically a friendly hodgepodge of everything. And this bad guy was died of the stroke in his sleep all by himself in New Year's night, maybe 2 years later. So I mean, somehow this is, this idiotic anecdote sort of gives you a picture of the scene. So otherwise, I followed. I was taken by the hand by some kind of a guardian angel, and it took me blindly through this thing.
How much of your sort of methodology for that work and later was influenced by Claire?
That's hard to say. I mean, first of all, methodologically, what I'm doing is pretty primitive. I mean, the little feedback book compared to the more ambitious book, 15 years later, is methodologically not only very naive, it is quite vulnerable. I mean, in the end, it is nothing but a catalog of instances that I have discovered, and I can basically only thank my stars that I did not invent more connections between these instances than I did, because usually they're unrelated to each other. And what is worse, I mean, many of them come out of patents, you know. For example, the English. I mean, I got a lot of them out of early British patents, which are nicely done, nicely illustrated, and all available in Munich. You know, other countries may have had patent corrections, but where they were not as well worked up, and so I might have missed them. You know? So it was pretty much a stab in the dark. Now, what Clem and the entire scene in Munich, they didn't criticize me for this. You know, some probably in America, if I had done this, they would have said, "Are you out of your mind? That is so stupid as an approach. That's not respectable. You cannot do it that way. That's not history. We don't know what this is, but history isn't." But they let me do it this way, and you know, in my innocence, I produced this thing, and protected by this innocence, it sort of came to a good end, you know. But afterwards, I basically shuddered what I had done there.
I think if you look at that, was it a conscious decision to exclude clocks from that talk? Were you saying that these do not?
Well, I didn't see any feedback in the clocks. It's that simple. Sure. Yeah. And, well, you know, in this other book, where I introduced the clocks, for me, clocks, the antithesis and antipode and enemy of everything that feedback stands for. It's the absolute contrast, and that's the only reason I included it in the other book. And so if I had to call it feedback, I had the clocks in my file. There were plenty of people who said I had to have clocks in them, and I said, "That's the feedback." They didn't understand feedback also. You can tell me why it wasn't fair.
Can you remember whether you actually looked at the Huygens conical pendulum?
I'm sure I did. Now, if you ask me what was it, I can't remember. Isn't it a temperature compensated pendulum, which it shortens itself with the expansion of through temperature, with rising?
No, I think it's the rotating pendulum rotates like that.
Well,
so,
then without not to get us bogged down, I'm not familiar with it anymore. But I think I must have convinced myself that it wasn't the feedback, because Huygens was a big figure that everybody knew about, and I'm certain that I got all the Huygens literature out and studied it as closely as I could, and came to the conclusion that it wasn't there. And I'm not even equipped now to defend it. If you said I was wrong with my diagnosis, maybe I was wrong, but nobody's ever told me so far.
Right. Out of that particular book and perhaps other the later papers, is there any particular device that you felt, oh, that is really the essence, and that is something that really attracts me?
Well, I didn't like the governor, the centrifugal governor, and in a way the centrifugal governor, I knew what it was from a little boy. The governor was nothing unfamiliar for me. I knew what that was, and that always made me smile. It's so pleasant, it's so charming. But I also liked this fantasy thing on windmills, you know. That I also was really smart. That was, so if I had to assign some kind of a column, I don't know, it would probably between those two. Anything, I mean, this float level stuff, that was not, I mean, it's only one way after all, you know. It's, but anyway, that didn't excite me. Thermostats were not that exciting. I said it would have been that. I could have a float level anecdote if you want to hear. I mean, I know I waste your time, but I'd love to tell that story. This had to do with beer. I was Valentine's War in Newark, New Jersey. It was a very trying tenants, and so they had a big vat full of beer, which fed these machines that filled beer into bottles. And also out of that came many little pipes and beer cans went on a carousel of some sort, you know, and also on the conveyor belt to get the plug on and out, you know. And so this all came out of this vat, and this had a lever control on it, basically, the toilet bowl, you know. And it didn't work. So I was dispatched to fix it, you know. And having a very good understanding of the toilet bowls were controlled, I did something. I sketched something out on a piece of paper, and I took it to the shop, and I said, build this, you know. Basically, the floor was a stick on it, you know, who acted on somehow. And so they put this on, and then they hit it after, I don't know how to hit this thing, so I put this on there. And then this was all wired up with lots of pneumatic tubing, and here's this big vat with you could have swum in it, and this beer in there, you know, and had this big hefty float, and then we said, go, and they let the beer in, and indeed, the beer came up, and this thing went up, stopped it, level was controlled, and this one package, absolutely. And so then, and this was when all the glass was, and so there was the floors, and then looked good. And so then, the next day, and this was in earnest, you know, when they were going to fill it into the bottles, I had proof in some connections, I was with pneumatic tubes. I simply hadn't paid attention. One of the connections was bad, so the thing did not work at all. Beer was on the top, and the top was flooded in beer, and it was a horrible mess, you know, but nobody saw it. Okay. So that was my favorite answer to the favorite system.
With that first book, over the years, have you had a lot of people contact you about it?
Well, you were one of them, I would say. A lot. I don't know a lot. But the book speaks for itself. I mean, it's at least an honest book, you know. The failings of it are right at the surface, and what you see is what you get, you know, it's that sort of thing. And no, I cannot say that. I mean, for a historian, the thing is simply not respected. It isn't even clear. So, in a way, I don't think historians include this or consider this a historical book. And so I was really quite eager to quickly produce some articles that were, let's say, more or less reasonably historical. So I got the stigma off of me, you know.
Well, I think that nicely brings us to the fact that you came to the Smithsonian here in Washington in 1968. Can you perhaps say about what your first job was?
Yes, well, again, I hate to do this, but this leads into story. At the Deutsches Museum, you know, I got this little project finished relatively quickly. We had sort of planned on 3 years, but this was easily done after 2.5, and so I had an easy last half year there. And so I took it easy and talked to people and looked around. A lot of Americans came through there. This was 68. I mean, the rich and fatal year 68. And so, and I started sending letters of application. I had always been, I mean, I liked Germany, but I also hated Germany. I had an ambivalent feeling to Germany, and I was always drawn to it, but when I was there, I also thought, no, I can't stand that place, you know? But I still have it. And so now being there, I was already looking at the States area, you know? But nevertheless, they didn't make me comfortable. I was very conceited, you know, I had done this all, and I thought I had nothing doing anything, looking at anything except something very interesting, you know what I mean? So I was writing applications to American universities, maybe 40 applications, and out of the 40, I got maybe 20 rejections, and the rest was silence. And so that clearly wasn't working. Now, part of it had to do with the year 68, but most of it had to do with I mean, you just don't get an academic job that way. So then I met a couple of people, and somehow they converged, and they had separate pull at the Smithsonian, but they both told me to write an application to the Smithsonian, and one of them actually was then the director of the American History Museum, then called History and Technology. And so he hired me. He was in Germany. And so I met him there, and they came to Munich, we became friends, and then he hired me. But he hired me for 1 year as a contractor. And he said that's only a trick, that's easier to do at the government, after all this was a government job. And for a year I can hire you quite quickly, and then we got you on board, and then we can go through the civil service, rigmarole, and until you get the permanent job. After I was a German citizen, and you know that's a little less straightforward than if I had been an American citizen. So that's what we did. And so then the question was, now what do we do with you? As a contractor, you have to fulfill the contract. What do we write into the contract? He said, what I've done before is get this person to catalog some area of the collections. Produce a catalog, and you produce this thing, and once it's finished, we got a product that we can lay on the table and judge, and we can say, yes, this satisfies the contract, or it doesn't, and clearly you're going to do one that satisfies it, and then the government is happy, and you have a publication. And then what is it going to be? And you know, I didn't need to think to tell what it was. I mean, you know, I had to make a little calculation in my head what the volume was. I mean, this on my part, when I said feedback devices, I had to make a calculation that it would be enough, but not too much, you know. And I was lucky. And then after a while, I recognized I had to keep all the electronic stuff. I had feedback wired into in some invisible way, and I could not be responsible for that. So it had to be without feedback. And then you probably have this, don't you? Yeah. Okay. It's really a better book than the success it had. I mean, absolutely. It absolutely, ended in obscurity. Oh, so that was that. And then they hired me at the Smithsonian. That was against my taste as a curator of tools. And tools, even if you expand it into production, was never a field of engineering that interested me in the slightest. Interested me a lot less even than power plants. And so I was, for my sins, I had to do the tools. And I didn't do too much, I must confess. I was not a good curator of tools. I wrote these articles instead. Later on, I made adjustments. I got into Crocs. In Crocs I enjoyed better, and so then.
In terms of of being at the museum and handling feedback devices, handling governors and devices there, did that give you any better sense of understanding the devices? Did it contribute in any way to developing your understanding? Because I imagine with the work at the Deutsche Museum on the original book, you worked largely from manuscripts. Yes.
I never worked with hardware in the the stuff that went through my hands at the Smithsonian. There were a lot of governors that were all, or in some cases, deeply hidden inside something like torpedoes, And in the torpedoes, turn of the century torpedoes, whitehead torpedoes, lots of ingenious feedback devices. Lots meaning at least there are 4 different systems that were controlled. But I didn't turn them on and tested them in anything, I went into some storage area deep under the dust. I got these torpedoes out, and if I was lucky, I could open them up to see where the stuff was. But usually even there I worked from drawings to see how this functioned. So then were governors and different rotary engines, mostly in reciprocal engines. Then there were a lot of them in arc lamps, where the distance was controlled by some feedback, and that feedback was a lot harder to spot. And some thermostats, not too many thermostats, as we are pretty typical anyway. So what came to light was not that exciting. Later on, when I was away from the tools and under mechanism, with the clocks, I had written control stuff as part of my subject. And so then I started collecting some feedback stuff. You've worked with it, I imagine but that was late in my time when I was already looking how to get away from the Smithsonian. And I would have liked to do some research on stuff, let's say that Transco and the various competitors, the stuff which I had experienced in practice, to write a story about that would have appealed to me. Yes. But I didn't get to it. And that stuff I had used, and to get that to work, you really have to have facilities that are absolutely up to snuff. I don't think you very easily get a Transco controller that's been laying around somewhere for 30 years to get that to work. You can't expect that to work immediately. You really have to be very proficient at getting this, sort of overhauling. And it's a system. And also all the transmitters, all of it has to fit together nicely before you have to contrive a process that this thing controls. That's nothing that you said.
I think when at that early time at the Smithsonian, I think did you assist Thomas Hughes with some of the work on the biography?
Yeah, yes.
Sperry?
Yes, well, he was. This was my recollection in the summer of 69. The time is getting close. I see his eyes in them. Anyway, and he had been, had a job, a fellowship of some sort at Johns Hopkins, and then this fellowship permitted him to spend a few months at the Smithsonian. And he had, by that time, his manuscript on the Sperry book was finished in some time. And so he gave me to look at chapters that might have involved feedback. And he didn't know what feedback was, and he didn't know how to spot it. And so I went over some chapters and basically straightened them out. I can't remember details, but my general recollections, a part of it is autopilot stuff. And there the feedback is very straightforward. I mean, there's no doubt about it, and it's clear. But then there's also the jail conversations. And my recollection is that there is genuine feedback in it, but it's a lot better disguised. It's not easy to see, but it's there. It's my recollection, and so I have to work that out.
Can I just look at the papers at in the early 1970s? Could I just establish the chronology?
Well, okay. For the Adam Smith comes first, and if you look in the conclusion of the little book, you find that theme already sounding, very superficial. So the first thing I did, might not even have gone to the Smithsonian, I was already at Adam Smith. And I must say, I enjoyed that. Thick, Broadway, 18th century book. I enjoyed that. I love Adam Smith. I mean, simply the way he thinks. Okay. And so there's that. And then the Maxwell book, article, and the other article about the Victorian physicists, it's basically one story. But I think if you want, and so I basically did them at the same time. But if you need a sequence, it would have the Maxwell came first. In a way, you could say the Maxwell story is the narrow story.
Yes.
And the other one is, in a way, also sort of table scratch, what was left over from that.
And were you, in writing those, were you influenced in the structure and style of them by what was going on in the history of technology? Because it was, if I recall, it was a time when there were changes in the approach to writing history of technology developing.
Well, as strange as it sounds, ridiculous as it sounds, in those days I thought of myself as cutting edge, And so I had people I admired in the field, and lots of others that I criticized, and so naturally I tried to do my best. But also the Maxwell article, I had almost designed for ISIS. I thought it would be good if I get an article into ISIS. And so I thought this is the way to go. Walter, the director of the museum who died, he was also the editor of ISIS. So it was easy to get it into ISIS, but nobody complained that I used full. That was an article that fitted nicely into ISIS. And now the one for the North Americans, I certainly didn't design that for it. I don't know how. It's possible that John Hughes told me that North Americans publishes stuff like that. And so I sent it to them, but then it was, nobody needed to tell me that fitted wonderfully for the North Americans, because most of the people involved were the fellows of the Royal Society. So that was easy. And the TNC had already dealt with the Adam Smith article. So I was not particularly motivated by what the peers thought, but I was very confident that these articles fitted nicely into the scene. And they did.
Yes. I was just thinking that the sort of the Victorian physicists who bring out the issue of networks.
Yes.
But
in all of these, the Adam Smith article made a certain splash. The others didn't. I didn't have the feeling that anybody was particularly pleased by the networks.
But in rereading those papers before I came here, it does seem in one way that we were being innovative. One looks at other articles in technology and culture at the time.
There is an article which I didn't bring up that involves this Charles Porter.
Yes.
You know, and I didn't enter this here, mostly to keep it manageable. But of course, that also involves steam engine governor, but then it drifts more into the machine engine dynamics of steam engines. And that article I was particularly proud of. And in fact, I got this prize for Usher Prize. But now, later, not now, but I read it in 20 years. But later, when I reread it, I did not like it anymore. And the reason was that the historians of technology of the time, and computers in particular, all had gotten into a very pompous tone of voice, of a very high kind of literary style. And I had fallen into that too. And now rereading it, I thought that was really quite disgusting. How could I ever write in this style? I mean, now when I write, I try to tone it down and get the pomposity out of it. And if I could get a light, ironic style, I'm not particularly succeeding, but that's what I'm dreaming of, you know? And that didn't.
And whilst this was happening, did you have what is undoubtedly your major work, authority?
Yes.
Did you have, was that idea developing during the early 70s?
Oh yes. Well, I was basically, I mean, to some extent, this was something deep in my under or subconscious, sort of poking around in my brain, rattling around, looking for a way of being dealt with, you know. But I didn't really. I mean, it was, for example, I was this way. I had, when I take the feedback concept, I could never quite make up my mind what the feedback concept was. What is this? It's not a mathematical concept, it's not a philosophical concept, it's not something on a wiring diagram. I couldn't find I couldn't make up my mind what category it belonged to. I still can't. And there were other concepts like that. And for example, there is in refrigeration, I think they call it regeneration, where you use some of the whole as a kind of pilot for the next circle. I cannot even quite imagine. So I was casting around whether, if this is a more general category of something, let's say an engineer, what are other specimens? What other things are analogous to it? But in the end, I didn't come up with that. I didn't come up with anything that satisfied me. B, I had the feeling this leads me astray. This leads me away from anything that anybody might be interested in. But I was looking for this. And then I call it mechanical analogies. You know, these metaphors that I came with. I was looking to see if among metaphors, you know, you can find collections of metaphors, to see if there were other metaphors that were technically interesting. Yeah, most of them are desperately trivial, you know. But the clock is semi-trivial. It can be trivial, but sometimes it isn't. Feedback never became a metaphor. Anyway, so I was looking around to checking out things like that, and all of it basically came out in negative. And then I came, and then there's this. I mean, I mentioned this in the paper to the story later today. There were two basic questions. One is, how come? What did Adam Smith and James Watt have together? You know, after all, they were Scotsmen. They lived at the same place at the same time, in the same social circles, and I don't think it's recorded that they met, but I think they must have met. You know, but now, when they supposedly met, did they say, no, let's invent feedback together, or James Watt told Adam Smith, now look here, how the economic system works as such and such, it works exactly like my steam engine going, obviously not, so that's not how. So, but still, the question then, what was, that was question number one, what links these two things? And the other is, why in the Middle Ages and the Renaissance? In the Renaissance was, I'm talking European Renaissance, was an intellectually lively area, everybody was that. And the books of Hero of Alexandria, who has absolutely striking and marvelous feedback devices in that, in wonderful illustration. And Hero's book was a bestseller. Everybody got it, and all the inventors looked at it and copied the tricks out of it. And they ignored feedback. They didn't use it. So why did they ignore this wonderful invention if they copied all the stupidities of it, So that wanted to be explained. So these two things occupy them, And two different answers. One, for the hero, the science about hero question, for me the answer was that the clock dominated the consciousness to such an extent that it silenced this thought, which admittedly is a far subtler thought than all that program control that's in the clock. That was the one answer. And for the Adam Smith James Watt question, that's an even subtler thing. That has to do with a totally different consciousness arriving in England out of the 17th century, out of the Cromwellian Revolution and the so-called Glorious Revolution, and that's where all these balances were, if not invented, they came into sway, they became perfect. And out of this arose, from the ground level up, something like feedback thinking. And James Watt is the one who gives it the finest formulations, but it's implied lots of other places. And I think James Watt simply comes out of that. But for James Watt is unfortunately, there's also a totally independent explanation possible, and that is, it's the Industrial Revolution, it's the time when some serious money is being spent in technology, and technology reaches a practical use as it has never had before. And so it's no wonder if all kinds of stuff is invented and becomes used that wasn't being used before. We didn't need the glorious revolution or that intellectual development that led to Adam Smith. You don't even need it to explain James Watt. So, in that sense, my authority, etc., is vulnerable too.
Yes. I think I'd better move on to this to 10 minutes. I might come back to a question about that. I think I'd like to move on really to museums.
Yes.
Because obviously you spent a large part of your life in museums. And I wondered whether you feel that either the Smithsonian or Deutsche Museum or any other museum really has given sufficient prominence to the feedback ideas.
Clearly not.
Yeah.
Well, I can tell you. The Smithsonian, I have no particular, nothing interesting to tell. In my time, of course they didn't have anything in particular. They at least had some steam engine governors they could look at, but they were not prominent, and the story wasn't being told. At the Deutsches Museum, there is a story. Before my time, meaning before I was director, they had made an attempt to have a hall, a gallery, named on what they called Regelungstechnik, which is more a control engineering. And it had fizzled. and it had fizzled, I would say, simply for lack of drive and competence of those that were involved. They claimed they didn't have the money, but I don't know. I mean, I don't know. I didn't particularly analyze it. It could have been done. There was a space reserved, but it didn't. So then I arrived on the scene, and I thought, if there's anything I can do, and anybody who can do it, then it would be me. And the same thing again, the gallery on feedback. And I physically, I failed. And the reason, and we had reserved a space in the vicinity of a big computer gallery that was created at the same time. And the guy who did that was a big computer professor at the Technical University Bank of Bennett, but he was also a hard man, and he was not a fan of this feedback stuff, and he thought he could deal with that. After all, it's just a little formula, and after all, I mean, it's mathematically trivial, and of course, a digital computer can deal with that, and so there's no need for a special gallery. And nevertheless, I think this concept is something so charming and something so universally important and useful and all the rest, and I want it there. And I want some of the classical feedback devices in display. So we had this area, reserved, a decent area. Let's say 500-600 square meters, which is 5,000-6,000 square feet. And so then the way we always did this at the Smithsonian was to find the top leader in the field, usually an academic, who would preside over an advisory council, which would have in it also people from the industry, people from academia, from the industry, and maybe even government or the non-profit world, and to put together a group of, let's say, 8 to 12, representing these fields, who would, especially in a field where the museum didn't have any competence of its own, would provide the intelligence, the thinking, including the language, the objects, to the extent that they were still needed, and the money, at least help in the fundraising, by providing the connections and all that. And so, conventionally, I, as the director, would have the job of locating this guy who would head this advisory council. And I went all over the place, looking for one. I had found for all kinds of fields. I had found the right person and found a good one where things went well. Here I couldn't find them. I went to one of the annual conferences, gave a speech, got myself a whopping flu out of it, and I was basically sort of received with a modest amount of contempt, And one of these candidates that I asked, he said, "What do you think?" Well, all the others naturally did this for nothing, for bono. He wanted money. And others had flimsy excuses. One said, "No, I'm dean, I cannot do in Germany the deanships rotate, everybody does it for 5 years, and they always think they're doing something absolutely amazing when they're the dean for 5 years, So I couldn't do it for that reason, and so on. They didn't do it. And for me, they behaved miserably, the profession. And then what we start?
5 minutes.
Okay, good. And then I came to now. When was this? This was mid-80s. And why was this? I came to the conclusion the this is a demoralized field. This field has been destroyed by the digital world. My friend, the digital guy, he said already, we don't need this field is obsolete, we can do everything digitally in something that's smaller than your pocket watch, So, and we can get the most complex mathematics into this thing. So what about the proportional and integral and derivative systems? What is this, And I think these guys all know it. They were banished to the outside. They were sitting there and playing irrelevant games, were mad at the world and each other, and kept themselves busy with that. And so here they were getting a glorious opportunity to present themselves to the world in all their glory, if not present, at least historical, and they spat at it. So that's what I have to say.
I think that answers one of the questions I was going to ask you, which is how does feedback control promote itself? And I think it's turned out one idea. I was also going to ask you, really, why, as perhaps a final question, why do you think that there has been no real take-up of feedback control amongst professional historians of technology?
One answer is a relatively trivial but powerful answer. The history of technology, as well as most of every other history, has since the 60s been entirely swallowed up and infected by the social history. And social history is above all a political thing. It's politically motivated, and it's the same people who sold us political correctness, And of course, it was born of necessity probably in the 60s, and now it dominates the entire academic scene and systematically destroys it. And it's still there. I still don't see much sign of relief. But for them, stuff like we do is first of all, it's too much work to work yourself into a technical subject and understand it. But besides, anyway, they're against it. And of course, it has no political utility for them whatsoever. And social history is not a thing for its own sake. They have an agenda. They want to control the academic departments or the education of mankind for their particular, So that is one thing. But for the other, this history becomes very quickly difficult. What I did is so that somebody can follow it relatively easily. But David Mendel's article, which in a way pleased me because that his topic is something I had flirted with in my time. This is usually the other origin of feedback. This is technically, narrowly speaking, the origin of feedback when he talks about it. And I might have done it. Really worked on it hard if I had not become a music director, But I cannot say what it could do. But his article is particularly good. Do you find it? I find the article not charming, not attractive, but hard-going, and in the end, it makes me ill-tempered. I can't quite say why, but it didn't really. Somebody did exactly what I thought everybody should do, and now I don't like it. So I thought, what's wrong with him? And I leave that unresolved. It would come to, I didn't read it carefully, I admit. He uses mannerism that annoy me, but I think what's wrong with it must be deeper than that. But anyway, so I have no decent answer for you.
I think we must draw to a close. Could I thank you, Otto? Thank you very much for giving us this interview.